Hi, I'm Lars. Welcome back to the shop. Today I'm going to use my CNC without using Fusion 360 or Carve Code or Vive Carve, anything like that. What I need to do is I need to create one of these. Now this here is a T-slot, and the way it works is you carve it into something, and then it's got a track in the back like that for a screw to go in. Okay, so you can hang stuff on the wall. What am I hanging on the wall? I'm finally getting this baby up on the wall. Now, in order to do that, I needed to find the center of the back. Found this, transferred it around to this side, put a line, did the same thing on the other side, put a line, drew a line in the middle here, measured in 7.5 inches because I know these are 15, and then I put a square up here like this on each of these points, and then I drew a line. So someplace in here I'm going to put this slot, someplace in this area here. I'm thinking right about here would be a good spot to start the slot. So this would be where the circle goes, and then we'll cut up like that and come back. And that should give me something I can just hang this on a wall. Alright? Now, I have run a test on this already, but I don't feel real comfortable just throwing this down there and setting this up and going and cutting it. So what I want to do is I'm going to run another test, but I'm going to have this piece of wood again sitting like this on top of this. Let's go and let me talk about how the code actually works before we get busy with all this. When I started working on CNC machines, we didn't have any software per se. We mainly used them to make simple, repeatable, mundane patterns, like boring a hole 2 inches deep and 1 inch in diameter by just cutting a bunch of circles. So we wrote code to do that. But this was something an operator could set in a piece of stock in a jig, and then hit a button and let it run, and it would run the same thing over and over and over again. And that was what we did. And then people started thinking, you know, if we start developing software, we can generate these things a lot easier. You've got AutoCAD coming in that could be transferred over into some smart cam tool, and that could actually create, you know, something that you don't need an operator to do this anymore. And then it became more and more intense, and then we had automated machines and robots doing this work. And needless to say, a lot of people are still doing tool and die, but not as many as there used to be. So this is what this video is about. It's about how to write simple G-code program. That's it. We're making a keyhole, and this is what a keyhole is. So a keyhole from a top view, you set your bit up, and then it will bore down, and then it will go across, and then it will come back, and then it will come back out. From a front side, if you were to take this little block here and tilt it up, this is what you would see. So this transfers straight down. You would see that this is all one size, and then there's actually the cut is actually being done underneath. You can't really see the top cut because this is kind of part of the wall. I guess I could have put a dotted line here, but that would have been a little more confusing, I think. If you were to take this side and flip it, you would see the right side of it, or looking in from this angle here, and you would see that the T-slot cutter is got a big piece on the bottom, and then it's got something that's cutting through the top of this. So that's what it looks like. It's a T, looks like an upside down T. You're going to drop in here, you're going to come down, and then you're going to come back and come out. So let's look at the work origins and the machine origin. So some things you got to really think about, like this is all 2D here. Now the machine works in a 3D world, and so do you. So you got to look at this in like this being the X and Y, and this being the Z and X. Okay, you can't see the Y plane here. You can see and you can't see the Z plane here. So the machine origin for me is down on the bottom left, right here. But if you look at the Z plane and the ZX plane, it is actually up above everything. That's where the Z is 0. So this would be X, Y, and Z0, and this is X, Y, and Z0. It's all about the way you're looking at it. You know, you're looking at your machine. So it's all about the way you're looking at your machine. The work origin from the X and Y point and Z from in the XY plane, it looks like it's sitting right here. And these two look like they're in the same plane, but they're not. This one is actually 5 inches this way and 4 inches back, and it's actually negative 4.625 down from this. But if you look in the XZ plane, you can see that this is down lower. And you can't see the Y, but you can see that the X is about 5 inches over. So this gives you a good reference. See, when we set your bit down, so you got to figure out where this, you have to figure out where you want this X, this crosshair to be. And when you do, you need to bring your bit right above it, don't touch it, and we'll need to probe. Okay? Now, we're not going to probe like you think. All right? The only thing you're going to do is you're going to set the X and Y to 0 at that point in time. So your work origin up on your screen now says I'm at 0. And then you're going to raise your bit up. Over here, you're going to raise your bit up, you're going to put your probe block under there, and you're going to come up, you're going to tap on Z. And then that's going to tell you how far down from here the Z is. This is not going to get stored anywhere. The Z will get stored in your 54, but your X and 0 are not. You're just going to be basing that off on the panel on the left-hand side on your screen. And this will make more sense when you actually see this happen on the Masso. But right now, we need to write some code. So in order to write code, you need to have Notepad++ or Notepad or Word. It doesn't really matter. As long as you save this, well, Word I wouldn't say unless you're going to save it as a text file. As long as you save it as an NC file, you should be fine. I'm going to name mine tslot.nc when I save it. So there's two websites, and I will put these in the description. Machinist Guides M-Codes and Machinist Guides G-Codes. There's not a lot of M-Codes. M-Codes are for manipulating your machine. Alright, so program stop. Here's your optional stop. Check the control panel, and if the optional stop switches on, the machine will stop just like with M0. M02 is the end of a program with no rewind. M3 turns your spindle on clockwise, and these here should be something that you're starting to understand, that you've seen these before. M05 spindle stop, M06 tool change, cooling on, cooling off, orient your spindle, end of program, and rewind. So that's something that's kind of cool. If you did an M30 at the end of yours, you could rewind it, then you could it would just rerun again. These are mainly for operators. There's a whole bunch of sub-program stuff and whatever down in through here, but we're only going to be working with a few of these. Some of the G codes, rapid travel. That means go as fast as you can go to get to that point. G01 is linear interpolation. G02 is a circular interpolation clockwise, counterclockwise, dwell, X-plane section, XZ, YZ, unit modes, inch mode, metric. So there's a whole bunch of these guys down through here. So I'll put these in the description. So the first thing you need to know is, how is a code program put together? Most people will put in a line number, and they'll do like number 010, and then the next one will be like number 020, and number 030, number 040. The reason they do this is because you can come back in and you can insert another line in here if you want. So I usually space them out in tens, and it's also easier to see because, if you get rid of the zeros, you can see what line number you're on. That'll correlate to the Masso machine. Like when they say you're on line 4, this is where you're at. So you can look into that. The first thing you need to do is you need to do, and I don't know why, but it's just been a habit of mine for since I was taught this way, and everybody does it. I don't know why, but first thing you need to do is you need to get a tool. So we're going to say tool 6. And we're going to throw an M06. And this tells us that this is my T-slot tool. And I'm just going to copy something out of here. And this is the definition of the bit. It's 0.375 deep, 0.375 wide. So this is a 3/8 inch deep and 3/8 inch wide bit. I'm going to let me show you what this bit looks like. It's router bit. So here's a 1/4 inch shank T-slot router bit, $9 for one bit. I kept looking at this and going, in order to buy this, and I got to pay shipping and everything else. And I don't want to spend a lot of money on this because this is one of those bits that you're rarely going to use. So we have a Harbor Freight bias. And I went in to look for router bits. And I picked up this set of router bits. And this is the bit that I actually have. And this is the bit that I'm going to use. It's a 3/8 inch keyhole bit. It'll run at 27,500 RPM, so I figured that was fine. And this is the nice little 3D model here, I guess, that shows you what the cut's going to be. It doesn't have a really good picture of this, but from the tip of this to right about here, I don't know if you can see the L right there, but that there is the 3/8 of an inch down from there to here. And this is what cuts this top little piece out of the top here. So I don't know if there's a better picture I can find over here on Amazon. There is. So if we look at this guy, you can see it right here. See how these have these L's on them? So from this point to this point, this high tip on mine is what 3/8 of an inch is. Okay? Just to let you know. So I wouldn't be worried about going out and buying a really expensive bit for this, because literally you're going to use this bit probably, unless you're using this bit a lot. But for me, I'll probably use this bit maybe 6 or 7 times in my entire life. So I just got a cheap bit. The next thing we need to do here is we need to tell it that we want to be on the XY plane. And then we need to tell it that we're going to use inches instead of metric, imperial. And then we're going to use G90, which is going to give us absolute mode. Now, this is where people start getting confused. What's the difference between absolute and relative? With that, we need to come back to this diagram. So absolute means when I go in and I tell this from G00 and we run code that says G00 X 1.0, it's going to move from this point 1 inch over here. It's going to move out, not move 1 inch. It's going to move to X is equal to 1. Okay? Now I could have said make this relative and do X to 1, and then that would work. But then coming back this way, it would have to say X move to X minus 1, which would bring me back to here. Now in absolute mode, if I'm doing this, it would be X1 to here, and if I did X minus 1, it would end up over here, because that's the absolute position. So once we go to X1, we need to go back to X0. So the first thing we need to do is we need to lower the bit. Now I'm going to use a G00, which is going to drop this bit as quickly as it can go. And we're going to drop down to 2.0. So 2 inches from the Z. Okay, because currently we're going to be sitting up over here. It's going to be sitting up over here somewhere. And we're going to drop 2 inches above this, because now we're working in this work origin, remember. After that, we're going to move to G, and we're going to go X00, and then we're going to go to Y00. And at that point, we should not, let's throw another 0 on here. We should not move anywhere. Nothing should happen with that line. And if we did everything right, then nothing will happen. So the next thing we want to do is we want to put an N70 in here. We want to go G00, and we're going to drop this down to just about touching the board. So 0.2 inches. It's a little under a 1/4 inch above the board. And at this point in time is when I usually turn on my spindle. So here comes an M03, and we're going to set the spindle rate to 16,000. And when we get to that, the spindle will kick up. And at this point, we need to take the machine and we're going to drop down on a G01. It's going to be linear. It's going to be a linear movement. And we're going to drop till negative 3.75. Alright, now let's go back to the diagram here so we can kind of talk about this a little bit. So the bit was up here initially. We dropped down on line 50, 2 inches above. Then we went to X0, Y0, just in case this thing got bumped out of the way. And when we set our X0, Y0, we want to put it right back where we wanted it. Then we're going to drop down to 0.2, turn the spindle on, and then we're going to cut down in negative from this. Since this is our 0 for Z, it's going to cut down in negative. And then we need to walk this way. And when we walk this way, we're going to go G01, and we're going to do X 1.0 at a speed rate of 30.0. So that's 30 inches per minute. Here we're going to put an 8.0 in there because I don't really want to bury that thing in there really quick. Alright, sorry I forgot that. Then with the 110, we're going to move it back. So once it gets there, then we're going to move back to 0.00. And we don't need to put an F30 on that because once this is set with the speed, it's already initiated. I could change it. I could come back a lot quicker or slower, but there's no need to do anything like that. Line 12, at that point in time, we're going to, as fast as we can, we're going to bring this back to 0.200. So we're just reversing what we did here. Now we're getting up to this level. And now that we're out, we're going to do a M05, which will turn the spindle off. And then line 140, we're going to do a G00, and we're going to take this to Z 2.0000. And then we're going to be back up at this spot right here. And at that point, we're going to tell the program, you're done. So that's an M02. And that's it. So we walk through this again, you're going to have the Z 2.0. You're going to be sitting up at this area here at 0. You're going to drop down to 2 inches. You're going to reassess where X and Y are. So it's going to make sure it's on 0. It's going to drop down again. It's going to turn the spindle on. It's going to drop down in here 3/8 of an inch, and then we're going to move at a feed rate of 8 inches per second, 8 inches per minute. Then we're going to move at 30 inches per minute to where X is equal to 1, which is out here. Then we're going to move 30 inches per minute, X is equal to 0. We're going to come right back where we were. Then we're going to raise up to 0.2 above, turn the spindle off, and then we're going to raise up to 2 inches. End of program. And that is what this is going to do. And we just need to save this as something like T-slot-NC. And that's it. If you save this with text, you probably want to make this all types. And then just save it as NC. And when you save it, it'll be NC. It won't be NC.txt. Okay? So there's nothing more to do to this except for put it on a jump drive and take it out to the shop. So let's take a run out there. Now that you see the code and you've seen how it works, alright, so I'm going to load this file up. It's called T-slot-NC, and there's the magic line. There's the magic file. Now this is what throws a lot of people off on this, okay, whenever you do something like a T-slot, because they don't see the hole, they don't see the path, they don't see it in three-dimensional like you would inside of a piece of software. But I assure you it is here. So when you're doing something like this, in order to probe it exactly where you want to start this bit, which is for me right up here. I just got to get this a little bit over a little bit. And I'm thinking right about there will work. And that looks like we're good. Now, at that point is where you need to come back to your code over here. You come back to the Masso and you need to zero this out, X and Y. Alright? And now we need to test for the Z. We need to bring this up, continuous mode, and we need to test the height of this. So it's easy as just probing with this bit. Alright, now if we take this and we bring the Z down, to right there, that is Z at 0, and we're sitting right, just barely touching that board. And that'll be good enough for what I'm doing. Now, I want to test this out before I do anything. So I'm going to go and I'm going to raise the Z up. And I'm going to hit, go to work origin, which should be perfect. And now I'm going to lay this down on here. And with the respect of this, we're going to put it right up at the very tip of this, like that, and like that. And we're going to see if this here is going to do exactly what I want it to do. If it doesn't, well, then we need to try this again. In order for me to do this on this, I've got to zero out on this top piece here. Now, what this guy should do, I'm going to hit work origin, should come straight up. We're going to go down 2 inches. It's going to tell it to go to 0, 0. It better stay where it's at. Then we're going to come down, we're going to get 2 inches above this. Then we're going to start the motor, and then we're going to drop down 0.3/8 of an inch. And then we're going to go 1 inch this way, and then we're going to come back to 0, and then we're going to come out. And I'm just going to hold this with my hand once I kick this off. Let's see what happens. Okay, that got a little bit wiggly because I was just holding it with my hand, but that's exactly what we're going to cut out. But we're going to cut that out on here. So I need to get this guy clamped down. There. And that shouldn't go anywhere. I'm going to put weight on it when we go. Alright, so now we need to reprobe this. Back to probing. And let's let this thing rip. Cross your fingers, because I am. And there it is, pretty much where I said it would be. Once you get a screw in the wall, you hang that in, and that will hang just like that. Looks pretty good. I hope you learned something in this video. I hope that this makes you less scared to create your own G-code. I really do. Knowing more about G-code will help you learn more about how your actual CNC machine works. Be able to do things like this and put keyholes on the back like that. This guy right here. Okay. But there's a lot more things that you can do. So I can use this keyhole code that I have now, and I can put that anywhere on anything, drop it down to where I need it to be, and hit play, and it will go in and cut, and that will work out. So like I said, I hope you guys learned something about this. Hope you're getting more familiar about your CNC machines and start doing some G-coding on your own. If you liked the video, please click like. Please subscribe to the channel. You guys are always welcome back here at the shop, and have a nice day.